Alright, this video is for section 5.3, and the objective is factoring ax squared plus bx plus c, where a, this leading coefficient, is not 1. As I said in class, there are many ways that this topic is taught. This is the way that I have found to be most effective. If you choose to do it my way, do not, I repeat, do not click on view an example or help me solve this, because this is not the strategy that they're going to use. If you want to use their strategy, that's fine. You're welcome to do that. But you need to choose which way you're going to do it, their way or my way. You don't have to do it my way. But if you do, don't try to watch what they do, because it's not going to make any sense to you. I'll be glad to answer any questions that you have if you will just call me. Alright, so this is the 4 steps that we're going to use. So by multiply, I mean take this first number and multiply it by this last number. And then we're going to rewrite the problem. So it's kind of like we're sliding the 7 over here to multiply by that. This will just become x squared. And whatever that middle term is, that's going to stay the same. And then 7 times 1 is 7. Now we're going to factor this using the strategy that we did in section 5.2, which is looking at the factors of 7, find factors that will combine to give you 8. Well, obviously with 7, there's only 1 in 7. So we factor this as x plus 1 times x plus 7. So that's the factor step. The divide step. Whatever you multiplied by, we're going to divide both of these by that number. If it simplifies to a whole number, like 7 divided by 7 is 1, you do that. If it doesn't, if you still have a fraction, this is where the slide part comes in. You're going to take this 7 and slide it up here to make this factor be 7x plus 1 times x plus 1. So the factorization of this is 7x plus 1 times x plus 1. And as I mentioned in class, this is not an absolute foolproof method, but a quick check is to make sure this first term times this first term equals this. First times first has to equal that. And last times last has to equal that. If you followed these strategies and those 2 criteria are met, then you can be reasonably sure, with pretty good reasonable, that that's the right answer. Alright, new problem. Number 2. 6x squared plus x minus 1. Whoops, you can't see that. Hold on. Let me make it where you can see it. There we go. Come on. Focus here. Okay. So remember our 4 steps. Multiply, factor, divide, slide. So multiply. We're going to multiply 6 times negative 1. And we're going to rewrite this. Like that. Then we're going to look at the factors of 6. And notice we've got to get a negative 6 when we multiply. Well, that means, wait a minute, let me see what I can do to make it where you can see it. Hold on. Having a little technical difficulty here. Why is it not focusing? Because this cord's in the way. Maybe. There we go. Okay, so back to the drawing board. We said in class that when this is negative, the signs have to be different. So the way that you can come up with a positive 1, remember, there's an invisible 1 right here, an understood 1 in front of that X. So to come up with a positive 1 with the signs being different, we need a positive 3 and a negative 2. So I'm going to factor this X minus 2 and X plus 3. So I multiplied, I factored. The third step is divide, and I divide by whatever I multiplied by right here. So this is going to be divided by 6. Now notice in this problem, neither one of them can divide to make a whole number, but they need to be simplified. 2 and 6 can both be divided by 2, and 3 and 6 can both be divided by 3. So you simplify the fraction. Now we're going to do the slide part. So this 3 is going to move up to here, and this 2 is going to move up to here. So I have 3x minus 1 and 2x plus 1. So that's what I claim as my factorization. So I'm going to write it over here under my problem, 3x minus 1 and 2x plus 1. Now I'm going to do my little check. Does 3x times 2x equal 6x squared? Yes, it does. Does negative 1 times positive 1 equal negative 1? Yes, it does. So that gives me a reasonable confidence that my answer is correct. All right, problem number 3. And let me pause here to remind you that you always look for a common factor first. So far, there's not been a common factor. So that's why I hadn't mentioned it. But you always consider that possibility. Alright, so I'm going to multiply and rewrite. And that 30 comes from multiplying the 6 times the 5. Now I'm going to come over here to the side and write factors of 30. Okay, so since it's a positive 30, the signs are going to be alike. They could both be positive, they could both be negative. Since this is negative, I know they're going to both be negative. So I need a combination that can give me an 8. And I observe that there's not one. There's no way you can have signs alike and come up with an 8. Well, if I can't do that, then that makes this problem what we call prime. Which means it... Why won't it stay in focus? Which means it cannot be factored. Now, I'm going to give you a hint. On my final exam, there will not be any that are prime. If I give you a problem to be factored, it can be factored. But in the homework, on my math lab, you will run across some that cannot be factored. And so when that happens, you just choose prime as the answer. Once I tell people that, they want to just write prime for everything, like nothing can be factored, but that's not the case. Alright, so now we're on problem number 4. I apologize. I do not know why it won't stay in focus. Alright, remember our 4 steps. First step is multiply. So I multiply 12 times negative 10. That's going to be a negative 120. I copy the x squared and I copy the minus 9x. That part doesn't change. Now, there's lots of factors for 120. So I'm just going to make my list. 1, 120. 2, 60. 3, 40. 4, 30. 5, 24. 6, 20. 7 won't work. 8 would be 115. 9 won't work. 10 and 12. 11 won't work, and I've already got 12 in my list, so now I know my list is complete. Now, as I said in class, this part's not required. If you can look at this and know which 2 numbers to use, you don't have to make this list, and you'll get to the point that you'll learn to recognize as soon as you hit the answer which one it is. Have I picked another problem that's prime? I sure have. Okay, I did not mean to do that. This is another one that's prime because there's no combination of these numbers that can give you 9. So we'll write prime again. Alright, I'm sorry. I didn't mean to do that. I meant to pick one that actually could be factored. Well, I can't even write the problem down right. Let's try that one more time. 30x to the third plus 55x squared plus 25x. Okay. So, I look at this and I make 2 observations. 5 will divide into all those numbers, so that's a common factor. And they all have a factor of x. So my first step, because if there's a common factor, you absolutely have to do that first. So I'm going to factor out the 5x, and I ask, what do I multiply by 5x to get 30x to the third? And that would be 6x squared. What do I multiply by 5x to get 55x squared? And that would be 11x. And what do I multiply by 5x to get 25x? And that would be 5. So I factored out my common factor. Now I'm going to do my 4 steps with just this part. My final answer is going to have the 5x in it. But for what I'm doing right now, I'd ignore that for the moment. So I'm going to multiply this 6 times this 5. Now, if you can immediately tell me the numbers that you multiply to get 30 and combine to get 11, great. If you can't, then you make your list. And since this is positive, the signs are alike and they're both positive. So those 2, if I add those 2, I'll get 11. So I do x plus 5, x plus 6 from those two factors. So I multiplied, I factored. The next step is to divide. And I divide these by whatever I multiplied by over here. So I'm going to divide by 6. If I can change it to a whole number, 6 divided by 6 is 1. I do that. If I can't change it to a whole number, I take this 6 and slide it up here. So I keep my 5x that I had as my common factor. Then I use 6x plus 5 and x plus 1. Now, as my check, and this is always a good thing to do, make sure 6x times x gives me 6x squared. And make sure 5 times 1 gives me 5. Which it does, so I feel good about that answer. Alright, let's do one more. Now, what's different about this one is it has two variables. And you may have seen this in section 5.2 as well. You still use the same strategy, but I'll show you how to deal with the second variable in a minute. So I'm going to multiply 25 times 6. That is 150. And I just put the b squared there with it. Now I'm going to write factors of 150. So 1, 150. 2, 75. 3, 50. 4 won't work. 5, 30. 6, 25. 7 won't work. 8 won't work. 9 won't work. 10 and 15. 11 won't work. 12 won't work. 13, 14, and I've already got 15, so that's my whole list. Now, since it's positive, I'm looking for two positive numbers that I can combine to get 25. So that would be 10 and 15. So I'm going to do A plus 10, B, and A plus 15, B. So if there's the second variable there, you just add it on to the end of these two factors. Next step is to divide by what I multiplied by. So I've got to divide by 25. Well, neither one of those becomes a whole number, but they can both be reduced. You can divide 5 into both of those, and you can divide 5 into both of those. Now I slide my 5s up there, so I get 5a plus 2b and 5a plus 3b. So that's what I'm claiming to be the answer. So I check, does 5a times 5a give me 25a squared? Yep. Does 2b times 3b give me 6b squared? Yep. So there's my answer. Alright, that should be enough to help you get started. As you're working through this section, if you run into problems, Call me, text me, email me. I'll be glad to help you. Have fun.